viewers, welcome back to another section of my tutorial videos. In this video, we're going to go through Kirchhoff's voltage law. Kirchhoff's voltage law simply states that in a closed loop, the algebraic sum of the voltages around the loop is equal to 0. When you hear algebraic, it means the combined sum of the voltages around the loop should be 0. Or in other words, you can say that in a closed loop, the voltage drops across each element is equal to the total voltage. And we've talked about that in the voltage drop session. So in this session, the Kirchhoff's law is saying that we are going to have voltage drops across elements in any loop. So this is a loop. See, A, B, G, H. So a loop is A, B, G, H, A. This loop, and in this loop, make sure that as you begin with A, you end with A, and that forms the complete loop. The sum of the voltage drops here in this, and I'll get the voltage drop here is what? IR, because voltage is IR. So I1 R1 plus here R3 I3 should be equal to V. And that is the law. It's saying that when you sum the voltage drops, it should equal the total voltage. Now, or you can say I1 R1 plus I3 R3 minus V equals 0. And that is the algebraic sum. In this loop, I have loop B, C, F, G, B. And in this loop, I have a voltage drop here, I2, R2. And I have this branch here. So let me make here R5. And I have my I5 going up. So you realize that when I take this loop, B, C, F, G, V, I move this direction, I2, R2, and this opposite to what I'm going, so it will be minus I5, R5. Then this place, there is nothing here. Here too is opposite. Minus I3, R3 will be equal to 0 because there is no voltage source here. So everything here will be equal to 0 because there is no voltage source. So the total voltage source here is 0. And that is the loop I'm talking about. This sums up Kirchhoff's voltage law. It's very simple, and I've taken you through some of the loops. So let's take a question here and see how we can apply. So find all the currents in all parts of the circuit below. So here I'm going to have this circuit here. I have a 32 volts. I have this here. I have this. I have this. Here is 20 volts. This is C, A, B, D, G, F. Then here I have 8 ohms. I have a current I3 coming down, 2 ohms, and this is 4 ohms. There is an I2 going this direction, then there's I1 coming. How do we find these currents using the Kirchhoff's laws? So, using the Kirchhoff laws, first of all, you know that KCL, the sum of currents, or the break sum of currents at this node will be 0. So my I1 entering, my I2 entering will be equal to my I3. Or you can say that minus I3 equals 0. So those entering is equal to those what leaving. And this is our first equation from the KCL. So we approach it step by step. Now from KVL, we need to take a loop. What loop are we taking? Let's take this loop. So loop A, B, E, F, A. That is this loop. You see that the total voltage is of 32, and it should be equal to the voltage drops across each point. The voltage drop across here is what? 2I1 plus here 8I3. And that is my second equation. And you know that I2 here is what? I1 plus I2. I'll make the subject. So 32 will be equal to 2I1 plus 8I1 plus I2. So I'm going to get 8I1, 8I2 plus 2I1. Hence 32. So final equation 32 is equal to 10I1 plus 8I2. And that is my third equation. So now let me take this loop. So loop BCGB. So loop BCGB. So in this loop, so let me bring that loop here. So in this loop BCGB, you realize that the total voltage here is what? 20. And see the direction I'm going. I'm going to this direction. This is my loop BCGB. So the total voltage is against my direction. So negative 20 is equal to, then I move this way. The I2 coming from this side is going this way and it's opposite. So negative 4I2, right? Then it will come again. So negative 20. Then it will move this direction. Then it will move up like this, and going up I'll get another minus 8I3, right? And that is my fourth equation. And you know I3 is I1 plus I2. So negative 20 is equal to negative 4I2 minus 8I1 plus I2. So negative 20 is equal to negative 4I2 minus 8I1 minus 8I2. So negative 20 will be equal to negative 12, negative 4, negative. So negative 12I2 minus 8I1. Let me multiply the negative out. I'll get 20 equals 12I2 minus 8I1 equation, plus equation 4. So now I'll take these two equations since I have I1, I2, I1, I2. So let me take equation 3. So I'll have 32 is equal to 10I1 plus 8I2. Then I solve these two simultaneously. And what am I getting? So you have 8, 12, 20, 10, 8, 32. So my I1 is equal to 4 amperes. My I2 is equal to negative 1 amperes. Then my I3 will be equal to what? From equation 1, my I3 is the sum of the two, and the sum of the two will give me 3 amperes. Thank you for joining me in this video. See you in my subsequent videos. Don't forget to like, to subscribe, and share.